sketch the graph of f of x equals 2/5 to the negative x power. Well, we can facilitate this process a little bit by rewriting the expression. We have 2/5 to the opposite of x. That could be thought of, and it may be helpful to do so, to write this as 2/5 to the negative 1, then to the x power. Of course, multiplying the exponents here, when you raise a power to a power, you multiply the exponents, and that would get us back to the negative x, or opposite of x, that we had in the original. But this gives us a way to see the behavior of the function a little more clearly. If you take the reciprocal of the 2/5, because you've raised it to a negative 1 exponent, we see we have 5/2 to the x. And 5/2 is a number that is greater than 1. In fact, it's 2.5. So we have an exponential function that has a base greater than 1. And whenever that's the case, we show exponential growth. And so our function is going to exhibit exponential growth, and we can approximate a graph of this by noting that f of 0 for any exponential function is equal to 1, and so the function will pass through the point 0, 1. From here on out, it's going to exhibit exponential growth. Let's get an approximation for a couple of values. Of course, x equal 1 is another easy one to compute. That gives us 2.5. So 2.5 and 1 gives us a point approximately here. And if we put in a f of 2, we would have 2.5 squared. 2 squared is 4, and 3 squared is 9, so we should get a value somewhere between 4 and 9. That'll be off of the chart that I've off of the graph that I've started to indicate here. But we can see it's going to be pretty high, and we're going to show that exponential growth pattern. Likewise, when x is negative, we'll be taking the reciprocal of 2.5 and then either squaring it or cubing it, or raising it to a power, and that will effectively drive that to 0 as we go to minus infinity. So an approximate shape for this graph is shown here.